Hi guys, today we're looking at quadratic functions. So we look at the most common one, and firstly let's start with our general formula or our normal formation of this function. Normally it is written as f at x is equal to a x squared plus bx plus c. Okay, or someone can just say it's y equal to ax squared plus b x plus c. It's the same thing. So let's first look at our normal one. This is most commonly to have f at x is equal to x squared. So if f at x is equal to x squared, it means our a is 1, our a is 1 here, and then our b is 0, our b is 0, and our c is 0 as well. So that's why we end up having x squared. Okay, so we do the same thing. We can look at the table. We can look at x, we can look at y, and then this is our table. Okay, we can look at it, and suppose this is our 0, 1, 2, minus 1, minus 2, minus 3, and we can just add 3 here, so we have 3. Okay, so let's look at f at x, f at 0, or let's start with f at minus 3. So we're looking at f at minus 3. F at minus 3 will be equal to minus 3 squared. This is the same as 9. And then f at minus 2 is equal to, in the bracket, squared, and this is the same as 4. So f at minus 1 is equal to minus 1 squared is equal to 1, and f at 0 is equal to 0 squared equal to 0. f at 1 is equal to 1 squared equal to 1, and f at 2 is equal to 2 squared is equal to 4, and we can look at f at 3. F at 3 is equal to 3 all squared equal to 9. So we can come back to our table where we have 9, we have 4, we have 1, we have 0, we have 1, we have 4. Sorry about that. So we can say we have 4, and we have 9. So simply we can sketch our graph like that. So this is our graph, f at x. So this is our we can say this is our 3, this is our 6, this is our 9. You can say the same thing. This is our 3, 6, and 9. Minus 3, minus 6, minus 9, minus 3, minus 6, minus 9. So we're looking at our coordinate, and we're taking the coordinate from the table. So from here and here, you can clearly see that we have our coordinate as minus 3 is to 9, and we have minus 2 is to 4, and we have minus 1 is to 1, and we have also 0 is to 0, 0 is to 0, and we also have 1 is to 1, and we have 2 is to 4, and we have 3 is to 9. Okay, let's look at minus 3 is to 9. Minus 3 is to 9 should be somewhere around here. Minus 3 is to 9 should be somewhere around here. And we have minus 2 is to 4, which will be somewhere around here. And let's look at minus 1 is to 1. Maybe it should be something here. Then we have 1 is to 1. That will be here. Then we have our minus 2 is to 4. Maybe it can be here. And then we have our 3 is to 9. So our graph will be nothing but something like this. So this is a parabola or a quadratic or a parabola. This is our parabola. So that is how we sketch our graph. So the shape of our graph will be just like this. This is a shape of our graph. It's facing upward. So we can say this graph is y equal to x squared. This is our graph. So we're looking at x and we're looking at y. So that is how we sketch our graph, and this is how we plot it. Okay, let's quickly move to a next one. So suppose now we have a graph like y is equal to minus x. So you see now in this case our a is -1. So we're looking at a negative graph. So what can we do here? Let's just sketch draw our table. Let's just have our table. Let's just have our table here. Okay, so let's just have 0, 1, 2, 3, and we have -1, -2. So let's look at f at x at -2. This would be minus into -2 all squared. You see, this is our x, just this one. This is our x, because you see our x or our f at x is equal to minus x squared. So when we're substituting, you just keep this negative outside here. You're not including it so that you're not making mistakes of the signs. Okay, so we will have f at -2 is the same as -4. Okay, so let's look at f at -1. F at -1 is minus into wherever there is x, we put, sorry, this was supposed to be minus x squared. Wherever we see x, we put a -1. So a -1 all squared, and this is nothing but a -1, because this here will just give us a +1, but we still have this negative here, this negative here. That's why we're getting -1. So let's look at f at 0. F at 0 should be just 0. And let's quickly look at f at 1. F at 1 would be minus into 1 all squared, and this should give us a -1. And then f at 2, this should be minus into 2 all squared. This should give us -4. And then f at 3 should be minus into 3 all squared, and it should give us -9. Okay, so let's quickly sketch our graph then. So this will be our graph here. This will be our graph here, and what we need the most in our graph, we need to have 9, -9. Okay, so this can be -3, -6, and -9. This can be 3, 6. This can be -3, -6. Sorry, it's +3, +6. This would be -3, minus 6. Let's just remove this one here. Okay, so we just have 3 and 6, and then we're saying that this is our x and this is our y, and then we're coming to fill in our table. So you can see that when x is equal to minus 2 here, we're getting minus 4, and when x is equal to minus 1, we're getting minus 1. When x is 0, we're getting 0. When x is 1, we're getting minus 1. When x is 2, we're getting minus 4. When x is 3, we're getting minus 9. Okay, so this means, let's look at 2. Negative 2 is to 4. Maybe it should be somewhere around here. And then we have minus 1. Sorry, we're looking at, this was a mistake. Okay, let's look at negative 2 is to 4. Let's say our negative 2 is here and negative 4 should be here. So point should be here, and we should have minus 1 is to minus 1 maybe here. Then we should have 0 is to 0 here, and we can have 1 is to minus 1 here, and we can have another one of which would be 2 is to minus 4 here. So the graph should be like that. The graph should look like that. The graph should be something like that. So our graph is facing downward, and hence the shape should be just something like that. Okay, so this is our graph. Y is equal to minus x squared. Okay, and then I think now you can see clearly from the previous example what we got was something like this. If you can recall from our previous example, was something like that. So here we're saying that we had y is equal to x squared. You see what negative a does to the graph, because now this graph is negative. That's why it's facing downward, because this graph is negative here, but this graph is positive. That's why it's facing upward. So that is the effectiveness, or how a affect the graph. If a is being negative, it means the graph will face downward, but if a is positive, it means that the graph will face upward. Okay, so let's carry on and look at C, how C affects the graph. Okay, on C, let's look at this table here to look at how C affects our graph. So suppose now our graph is like f at x is equal to ax squared plus c. You remember we said our original format or equation would be f at x is equal to ax squared plus bx plus c, but in this case we're saying that this term here is 0, so we're just having c and the first term. Okay, so let's quickly look at it. Let's look at some different graph maybe at the same time and see. Let's try to use this place for our table. Let's say we have x and we have y1, y2, y3 maybe. We can also look at y4 as well. So this is our table. You will see where I'm going with this just now. This is our table. Okay, 1, 2, 3, 4. Just now you'll see where I'm going with this table here. Okay, suppose we're starting from 0, 1, 2, and we have minus 1, minus 2. Okay, and then let's say our y1 y1 is equal to y1 is equal to y1 is equal to x squared minus 2. X squared minus 2 is our y1, x squared minus 2, and let's say our y2 is equal to x squared plus 1, and let's say our y3 is equal to x squared plus 2, and let's say we have our y4 is x squared minus 1. Okay, so we're looking at these graphs here, and then we're just substituting. So we're looking at -1 at -2. So from y1, if you substitute -2, let's say you replace this x here with -2, you just put -2, and you might need your calculator so that you can work faster here. So what we will have open the bracket, we're putting a -2, we're putting a square, so it's 4 minus 2. 4 minus 2, it will be just 2. So if you put a -2 here, it will be 2, so this will be 2. Or let's just do it in one example, and then the rest will just do the shortcuts. Okay, so let's look at -1. So we're saying f at -1 is equal to -1 squared minus 2. So this is nothing but equal to -1. You can put it on a calculator, you will see what I'm talking about. So this will be just be in a -1. So let's quickly look at f at 0. F at 1 0 is equal to 0 squared minus 2. So this is -2. And then let's look at f at 1. F at 1, we just have 1 all squared minus 2, so it's 1 minus 2, so this will be nothing but -1. So let's look at f at 2. F at 2 should be 2 squared minus 2, so this will give us 4 minus 2, so that is just 2 again. Okay, so we're doing the same thing with y1. So suppose we're putting 2 here, 2 squared should be 4 plus 1 is 5, and then we're putting 1 minus 1 squared, that should be 1, so we're getting 2, and then if we're putting 0, this would be 1, and then if we're putting 1, this should be 1 plus 1, and this give us 2, and then let's say we're putting 2, it should give us 5. You see, we're using the same values of x so our coordinate will be -2 is to 2, but on the next graph, of which is y2, we're using -2 is to 5. So we're using the same x-axis but for different graphs. Okay, that's why we're just making one table. Okay, let's try to see now on the next one. Let's say if you're putting 2 here in this graph, now we're substituting 2. If you put -2, it should be 4, so it should be 6, because it would be 2 squared plus 2, that is 6, and then you put 1, it should look like 3. You put 0, it should be 2, and you put 1. If you put 1, it will be 3. If you put 2, it will be 6. So let's look at the last one, our last one here. So let's say we put our -2, it would be 1, because it would be I think it would be 1. if you're looking at this one here, it should be minus 2 squared. That should give us 4, hence we'll have 3 here. And let's put 1. If we're putting 1, we have 0, because if you're putting 1, it will be 0. If you're putting 1, it will be 0. If you're putting 0, it will be minus 1. And if you're putting 1, it will be 0. Okay, so if you're putting 2, it should be 3. Okay, let's look at these graphs here. So this is our graph. So we want to check what does C does on the graph. So the effectiveness of C on this parabola graph. Okay, so what we're looking at here, we have up to 6, we can say. So we can look at 2, 4, 6. We can look at 2, 4, 6. We can look at minus 2, minus 4. We can look at minus 2, minus 4. Okay, so let's look at our first graph, of which is this one here. So where we have minus 2 is to 2, minus 2 is to 2, minus 2 is to 2, and we have minus 1 is to minus 1. We have minus 1 is to minus 1, of which should be here, this point here. And we have 0 is to minus 2. We have 0 is to minus 2. We have 0 is to minus 2. So when x is 0, we have minus 2. Y is minus 2. So we have something like that. Because we had, so it should be here. Our minus 1 is to minus 1 should be here, not here. Okay, and then after that we have 0 is to minus 2. Do we have 1 is to minus 1, and we have 2 is to 2. So that will be a graph. So it's tens here, it goes like that, and it goes like that. So this is our graph 1. So this is our y1 is equal to x squared minus 2. Okay, so let's look at another one. We're looking at y2 now. So you see in y2 we have minus 2 is to 5, minus 2 is to 5. Maybe it should be here. So it should be here. Minus 2 is to 5. Minus 2 is to 5 should be here. Should be minus 2 is to 5. And we have minus 1 is to 2. Minus 1 is to 2. Maybe it can be here. And we have 0 is to 1. 0 is to 1. So same thing, we'll have a graph like that. So our graph is facing upward. So our graph is just like that. That is our graph here. So you can see these two graphs are positive, because here we have positive. You have positive here, you have positive here. So that's why they're facing upward, because they both positive, and this one is y2 equal to x squared plus 1. Okay, so both of them, they are positive. Let's look at y3. Let's look at y3. y3 is okay, let's look at y3. We have minus 2 is to 6. Minus 2 is to 6. So it's something like here. Minus 2 is to 6. And we have minus 1 is to 3. So something like here. And we have 0 is to 2. 0 is to 2 here. And then we have 1 is to 3 here. And we have 2 is to 6 here. So this graph will look like something like that. So this graph will look like something like that. So that will be our graph. Okay, but this one is y3 equal to x squared plus 2, x squared plus 2. Let's look at another one. We can just assume another graph will be here, our y4 will be here, this will be our y4. So you see what C does. If C is negative, it shifts the graph downward by 1 unit, because we have -1 here. But when we had -2, you see from the original graph that we sketched, of which would be here, from the original graph, so if C is -2, it's just shift downward by 2 units, and then that is what the element of C does in the graph. So that's what we were looking at in a parabola. So we're looking at what C graph, or what C does in the graph. So without a doubt, if you're looking at the graph, you can simply, whenever you're seeing a graph, maybe that is in the form of f at x is equal to a x squared plus c. This graph can be something like maybe f at x is equal to x squared plus 6. Whenever you see a graph in this format, and then you know if C is positive, as it is positive here, then you will know that it shifted by 6 units up. So basically this is what you can look at. To conclude, let's just do this one as a conclusion of this video. So you see, this is our original graph. Let's look like that. That is our original graph. So if C is negative, like maybe -2, it would be shifted 2 units up. So it will be like that. But if it's negative, if it's a negative graph, it will look like that. So this will always be our y is equal to x squared, and this will be always be our y is equal to minus x squared. Then we can also look at maybe shifting the graph like that. It doesn't matter what the unit is, because it can still be shifted just like that, only to find that maybe this is -9. The graph will be x squared minus 9. Then this is what the C does. So now next, on our next example, because remember we said the format is like this, it's a x squared plus bx plus c, and now we discuss what a does in the graph. The a is just telling us the shape, whether it's facing downward or upward, if it's negative or it's positive. But we still need to look at a maybe being 2 or 3, like maybe in this case where you can have x, f at x is equal to 3 x squared, because you see now, yes, our a is positive, but it's 3. So the bigger the a, we need to check what that does to the graph, and then we need to check now what b does to the graph. And we need also, now we know already what c does in the graph. The c is shifting it up or down depending on the sign of c. Okay, so that's what I had today. If you're looking at the quadratic, or when we're looking at parabola sketching and analyzing the graph. Thank you so much.